Hello, grade 12. Welcome back to the channel, Science Therapy. In today's lesson, we're going to be looking at proportionality theorem. And without any further ado, let's look at these activities here. Just simple activities to set up the mood. So we have in the accompanying figure, MS is parallel to QR. And then we are given furthermore, PM is X centimeter, MQ is 2 centimeter. PS is X plus 2 centimeter and SR is 3 centimeter. Okay, so now this is what we have here, the diagram. And then we can see that we've been given actual lengths. So looking at proportionality theorem, we know that proportionality theorem simply states that if we draw a line parallel to one side of the triangle, then this line will cause the two lines to divide in such a way that the sides will be in proportion, right? So that means we are drawing this line here parallel to this one side, and then it makes this two sides of the triangle here to be in proportion. So this side here over this side is in proportion to this side over that side. So basically that's what this all means, right? Then they say now calculate with tracing the value of X. Now to calculate the value of X, this is how we go about it. We just simply say PM over MQ is equals to PS over SR. And then we'll say prop theorem. And then the PM is X, and then the MQ, we can see that it is 2. Then PS here is X plus 2, and then SR is 3, right? Now, at this point, to find our X, we just simply need to cross multiply here. Then this will give us 3X is equals to 2X plus 4. Now, if we subtract this, this is X is equals to 4 centimeter, right? And just like that, we have our value for X. Okay, let's proceed. Number 2, it says in triangle ABC, DE is parallel to BC, AB is 6 centimeter. So we can say that that was not shown. We can show it here, 6 centimeter. And AD is X centimeter. AE is 5 centimeter. EC is 3 centimeter. Determine with tracing the value of X. So now that we are given this whole 6 centimeter here, the whole length for AB, we can use that in proportion to the whole length here, which is AC. So this is going to be AB over, now look at how I'm taking this one. So now that I'm taking the whole length AB, I need to also come here and take the whole length AC because it's in proportion to that AB. And then I'm going to be using AD because that's where the X is. So if I'm taking AD here, I need to come in here and take the side that is in proportion to that, which is what? AE. Then that's AB over AD equal to what? AC over AE. And then what do we say? Prop theorem. And then our AB, we can just go ahead and substitute 6. And then AD is X. And then our AC here, if we add the 5 and 3, this gives us 8 centimeter. So we have 8, and then our AE here is 5. Now we can all see at this point, we just need to cross multiply. So we'll have 8x, 6 multiplied by 5 is 30. Then we have to divide both sides by 8. So this, if we punch in a calculator, it gives us 3.75 centimeter, right? Okay. Now, let's proceed. For 3, it says in the accompanying figure, BF is parallel to CG, which is parallel to DH, and DH is parallel to EH. Furthermore, AB is 1 centimeter, BC is 3 centimeter, and CD is 1 centimeter. So here, once again, we are given actual lengths. Then they say, write down the value of the following ratios. AG over GH. So now we're going to go ahead and identify AG and GH. So this is our AG, like this. and then this is our GH. Now, in order to write the ratio for this one, we have to go ahead and pick the sides from this side here that are in proportion to AG over GH. So if we are looking at it from this angle here, we can see that AG went all the way and came across this parallel line here, which is CG. So we're just going to go along with this line here. And then there we go. It leads us to this side, AC. And then from here, we can see GH. It went through the parallel line DH. And then we can see that what we have there is CD. And for all this, we have values. So to calculate that, we will say AC, the total length of AC is this 1 plus 3. So this will give us 4 centimeter. But the length for DC is just this 1 centimeter. So this is in proportion to AG over GH. So we can start by saying AG over GH is in proportion to AC over DC or CD. And then we just simply say prop theorem. And then for this one, we can give the pair of parallel lines because we can see there are so many parallel lines. So we want to show them that we saw that within this parallel line DG, CG, pardon me, CG over parallel to DH. So it's CG parallel to DH, as we can see from here. Now, from here, we just simply say AG over GH is equals to AC is 4, and then CD is 1. So the ratio becomes 4 over 1. So you just leave it like that as in ratio form. Then AD over DE, let's go ahead and identify AD over DE. So if we erase here, we have the AD, so this is AD, and then over DE. But then let's not forget that we already have the ratio representing this, right? So if we look at it from this angle here, you see this is AD crossing all over to which parallel line? This parallel line that we are seeing here, which is DG, right? And then the DE here crossing over to this parallel line that we see EH. So the DE is in proportion to GH, right? So we can simply say AD over DE. AD is in proportion to AG and the DE in proportion to GH. But then remember, we've already calculated AG over GH from the previous question, which gave us 4 is to 1, right? So this gave us 4 is to 1. Now, looking at this, we can see that, okay, we can simply say AD over DE as a ratio is 4 over 1. So here the reason is prop theorem. And then our parallel lines, DG parallel to EH. Okay, so now 3.2 says determine the length of DE. Determine the length of DE. So to determine the length of DE, we can simply say AD using the same ratio that we got from the previous question. So 3.2 can say AD over DE is equals to AG over GH. Now, if we are considering the true lengths of AD over DE, we only have the length, the true length of AD, which is 1 plus 3 plus 5. This gives us 5 centimeters. So we go ahead here and substitute 5. We don't have the length of DE, so we'll say DE here. But then what is our AG? AG is represented by that 4 there. and then over what? Over 1. So to calculate this, we can just cross multiply here. So this will give us 4DE and then equal to 5. So if we divide both sides by 4, then the DE here is supposed to be what? So let's say 5 over 4. That's 1.25. 1.25 centimeter. So that's how you calculate that. So note how the ratio and the actual length are not actually the same thing. So with this one, you couldn't say the ratio is 5 over 1 because you didn't have the value here. So you needed to say it's in proportion to AG over GH. So that means the ratio is 4:1. Now, if we want to prove that, let's prove that truly the ratio there will be 4:1. So if we say AD, the actual length is 5, and then the DE we just calculated to be 1.25. If you can simply punch in your calculator, then say 5 divided by 1.25, you get 4, which we know 4 is the same as 4 over 1, right? So this is simply, if we write it in ratio form like this, 5:1.25, we know that we'll have to divide both sides by the smallest number, which is 1.25. Then 1.25 goes 4 times into 5, but 1.25 only goes once into 1.25. So that's the ratio. So the ratio and the actual lengths are not the same thing. Okay, so let's proceed. Now, question 4 says, in the accompanying figure, N is a point on PQ and M is a point on PR of triangle PQR such that NM is parallel to QR. T is a point on QR such that NT is parallel to PR, and then QT is to TR has a ratio of 3:2. So you can also write this in this form: QT over TR is equals to 3/2. So remember, you can write it in ratio form or you can write it as a fraction. It's still the same thing. Now, when we continue reading, it says PQ is 30 units and PM is 16 units. Right. Okay. So now they're asking us to calculate the length. So let's go ahead and substitute what we are given here. We are given QT to TR. So this is, let's use 3K because these are not actual lengths, they're ratios. So we're going to say 3K, 2K. Right. And then now we know the whole length of this, we can say it's 5K. Right. So now we are required to calculate the length of PN. Then we are given PQ. PQ we are given to be 30. And then PM here we are given to be 16 units. Right. So to calculate PN, we can simply just use this set of triangle here, parallel lines, to say, okay, if we are taking all this as the parallel line, we know that the ratio of PN, the ratio of PQ, all of PQ here, let's start with the whole of PQ, is equivalent to the ratio of all of RQ, right? And then again, if we are taking a PN, this should correspond to the ratio of TR. Right. So we can simply say PQ over PN is equal to what? Is equals to the whole of QR or RQ over what? Over TR. So when we are taking this, it's in proportion to that. When we are taking that, it's in proportion to this, right? So hope it makes sense. And then we say prop theorem. Then let's give them the pair of parallel lines that we used. So it was based on this parallel lines, which is PR parallel to NT. So this was the line drawn parallel to one side of the triangle. Then PQ, we've been given it's 30. Then we don't know PN. That's what we are trying to calculate. But the RQ here is 5K. So let's go ahead and substitute 5K. And then the TR is 2K. right? So we know the K and K will cancel out eventually. Then if we cross multiply here, that's 30 times 2. So it gives us 60. And then we have 5 times Pn. So we are supposed to divide by 5 both sides. Then if we say 60 divided by 5, that gives us a value of Pn being 12. So it's 12 units. 12 units. Right. So another way you could have calculated this is to identify that actually you could identify that the ratio of Qt over TR is actually in the same proportion as Qn over Pn. So this is just another way to solve the same question. Now, remember the ratio that we have for this is 3 over 2, right? So you can use the same ratio for Qn over Pn. So if you have 3 over 2, that means the Qn here could be 3p, and then this could be 2p, right? So to calculate here, you would simply say, okay, I have 2p as a ratio for Pn, and then the total ratio is 5p. So you could simply say to calculate Pn, I could say 2p over the total ratio of 5p when you add them together. So the sum of ratios is 5p, then multiplied by, since you have the total length for PQ is 30, this is still supposed to give you 12. So if we say 2 over 5 multiplied by 30, this still gives us Pn is equals to 12 units. 12 units. So yeah, many ways to kill a cat. Many ways to kill a cat. Then MR, to calculate the length for MR. So where is our MR? This is our MR. But then remember, we've been given 16 units here. And then we found that this is 12. And then we found that this is 30 here. So now that we know that this is 30, this is 12, we can simply subtract the 2 here. And then we get 18, right? So we can see that there is a parallel line drawn to one side of the triangle, which means our prop theorem applies. So again, for this one, we can simply say Pn over NQ or Qn is equals to Pm over Mr, right? So we can see, once again, this is prop theorem because there's a line drawn parallel to one side. Then Nm for Nm parallel to Qr. Okay, so what is the value for Pn? We can just use the actual length. So that's 12 over 18, which if you can check here, this still gives you the same ratio that we got of 2 over 3. So this is still 2p over 3p. So you can just decide whether you use the ratio, so you just use the actual length. So the Pm is 16 and then over Mr. So if you cross multiply this, that's okay, let me just go ahead and simplify this. I don't want to work with big numbers. Then 16 over Mr. Then let's cross multiply from here. I have 2 Mr is equals to 3 times 16. Then that's 48. And then if we divide both sides by 2, our Mr is 24 units. So 24 units. So yes, and that's how you calculate that one, guys. Okay, let's proceed. 5, you are given in the diagram E, H, D, and G are points on the side of triangle ABC. GH is parallel to AC and ED is parallel to BC. HG cuts ED at K. AD over DC is 5 over 3 and BG over GC is 2 over 1. So we are given what? Ratios, right? So these are ratios. And then let's fill in those ratios. We have AD. So let's say it's 5K because we are given ratios, and DC is 3K, right? And then BG, where is BG? Is 2K, and then GC is, okay, let's use 2P because we cannot use K and K. Then here it's 1P. Then down here we are given that AB is 24 units, and then they say determine, given reasons, the length of AE, the length of AE. So number one, we can see from this, let's fill in the AB that we are given. So AB is 24 units. So again, this one is similar to the one that we just solved. We can either take the fact that these ones are in proportion, say AD over DC is in proportion to AE over EB. And then we just simply say prop theorem. And then that's ED over BC. Okay, so now that we have the ratio here, 5K, 3K, we can simply say that also AE over EB has the same ratio, which is 5 over 3. So if we have identified that, we can simply identify this one, let's say, as 5x and 3x. So using the total ratio, that's 5x and 3x, that's 8x. So to look for AE, we can simply say, okay, AE, what is the ratio for AE? Is 5x. But what is the total length of the ratios, or the total of ratios? Is 8x. Then multiplied by the total length for AB, that's 24. So this is 5 parts of 24. This is 3 parts of 24. So we are trying to get 5 parts out of 8 parts for 24. Then that's 5 over 8 times 24. This gives us AE 15 units. And then, so this is one way to solve it. This is one way to solve it, 15 units. Or you can just go with the one that we are used to, so which is this. So the one that we are all used to is, we're going to say this one is over this one is in proportion to AE over EB. So AD over DC is in proportion to AE over EB. And then we just go AD over DC is equals to, so, okay. Then let's calculate AH. To calculate AH, what is it that we are going to do? So where's AH? We can see that AH is here. Then looking at this, we can see that this is AH touching which parallel line? HG. And then if we take it from AH, we go to HB. It's so this is within which parallel lines? The parallel line AC and HG, as you can see here. So from this parallel line AG over HG, then this should be in proportion to BG and GC. So note how I'll be taking this. So this is the ratio. What are we supposed to calculate? AH, right? So if I'm taking AH this way, I should also take this. So AH is in proportion to GH. GC is in proportion to GC, meant to say. And then HB over HB, which should be in proportion to what? To GB. So that's it. Now, we want to calculate the length of AH, but remember BG here, we were given 2P, and then GC here, we were given 1P, right? So to calculate for this one, we could simply say we are given that the length of AB here is 24, right? And then using this ratio, AH over GB, so AH over HB is equals to GC, which is 1, and GB is 2. So this will give us a ratio of 1 over 2, or 1 is to 2. Now that means this is one part. We can say this is 1y, and then all of this will be 2y. So to calculate AH, we can simply say we have 3 parts for this 24, but we are only looking for one part of 24. So we're simply going to say AH is equals to 1 over 3, because the total of all the ratios is 3. So it's 1y plus 3y. So that's 1y over 3y multiplied by the total length of AB, which is 24. So to get my AH, that's 1 over 3 times 24. And this should give me 8 centimeters. Okay, good. So we can say that it's pretty simple to calculate it using parts. Okay, then question 6, it says in the diagram below, triangle AFC is drawn. B lies on AC with D and E on CF. Then BD is parallel to AE and BE is parallel to AF. CB is to CA, has a ratio of 5:9. So again, you can also write this in the form of a fraction. CB over CA is 5/9. Okay. Then let's proceed. They say if the length of CA is 18 units. So we are given the length of CA, whole length of CA is 18 units. Okay, and then BA, they say find the length of BA. So if all of this is 18, we must find the length for BA. So let's go back and see what we've been given. We've been given CB to CA is 5:9. So where is CB? CB is here, so we can just say this is 5K. So let's say this one will be 5K. And then CA, so the whole of CA, it's all the way from here up until this point. So this whole length here has a ratio of 9K. So if this is 5K, this is 9K, that means here we agree that this is 4K. So 4 plus 5 will give us that 9K, right? Now to calculate the length of BA, let's use parts again. Now that we have BA, it's 4K. So we'll say to calculate BA, BA is 4 parts of 18. So that's 4K over the total of ratios, which is 9K, multiplied by the total length, which is 18. So if we say 4/9 multiplied by 18, this will give us BA is 8 units. 8 units. Then Determine area of triangle BDC over the area of triangle BED. Now with this one, I want you to see something. So let's mark the triangles that we are given here, BDC. So this is BDC. Now from the proof, you will remember that if we have something like this here, a line being drawn from here up until this point here, this line, we call it a perpendicular height. So here we've constructed a perpendicular height, which should be equal to 90 degrees. So using angles on a straight line, if this is 90 degrees, we know that also here should be 90 degrees. Now, the other triangle that we are looking for is this one, BED, which is the triangle there. So now we must calculate the area of triangle BDC over the area of BED. Looking at these two triangles, we can see now that they have the same they have the same height, which is the constructed height BD, right? Perpendicular height. So to calculate our area, we know the formula for area is area. So we'll say area of triangle BDC is equals to half base times height over again the area of triangle BED over half base times height. Now, looking at this triangle, what is the base of this triangle here? If we are looking at it from this side, we know that the base will be here. So this will be our base. And then also for this one, this will be our base. Right. So what are we trying to achieve here? We are trying to get the ratio for this side here, CD over DE, right? Which should be in the same ratio as this one here. Remember, these are parallel lines, which should be in the same ratio as CB over BA. Now you get the whole point of calculating that. Now, what is our base? Half the base for this red triangle, BDC, is CD. And then what is our height? Our height is BD. Then over half, what is the base for the blue triangle? BED. The base is DE over multiplied by BD, which is the height. Now we can see that the BD and BD can cancel out. So BD, the half and half can also cancel out. Then we are left with CD over DE. But then the CD over DE is in proportion to, so we'll say, but CD over DE is in proportion to CB over BA. Why? Prop theorem, a line drawn parallel to one side of the triangle. So it's prop theorem. For which parallel lines? These parallel lines that we are seeing here. So now the value of CD over DE, or rather the value for area of triangle BDC over area of triangle BED is, so remember here we had 5K and then here we had 4K. So if we do that, 5 divided by 4, so that's 5 over 4. That becomes our ratio. So for 6.2, you have it like that. CD over D is 5 over 4. So that's the ratio of the area of triangle BDC over the area of triangle BED. So nice. Okay, now let's look at 6.3 here. It says if the length of CF is 45, so we are given the whole length of CF is 45 units. They say find the length of DE. So we must find the length here of DE. Okay, Now, looking at this, from the previous question, we deduced that these lines here are in proportion. CB is in proportion to CD, and then BA proportion to DE. So because here we had 5K and then this was 4K, we deduced that the values for this one here should be 5P and 4P, right? Okay, so if we have this, we can simply say that these two lines are in proportion, seeing that there's a line drawn parallel to one side of this triangle. So we see that they're in proportion, and we've proven that. But then if we look at it from this perspective, you will see something magical about it. So we have CB here and BA, considering these parallel lines, which is BE and AF, we can say that not only is CB over BA in proportion to CD over DE, it is also in proportion to CE over EF. So what can we say about this? We can simply say that the CE here is in proportion to CB. So this is supposed to be 5Y, right? And then the BA in proportion to EF, this is supposed to be 4Y. So now we know that CB over BA is in proportion to CD over DE, right? But again, CB, the same CB over BA is in proportion to CE over EF. Now, what can we do about that information? So let's make use of that information. We can start by just saying the whole length here is 45, right? So if we wanted the length for CE, we could simply say CE, considering this, considering what we have here, we could say to calculate CE, this is 5Y over the total length, which is 9Y. So that's 5Y over 9Y multiplied by 45. And then if we punch this in our calculator, that's 5 over 9 multiplied by 45. The CE is equals to 25 units. So the 25 units is this, CE. So that's 25. Now, but again, making use of this here, we can say that it's still in the same proportion. So we have 5P and 4P here. So to calculate the DE that we are looking for, which is, they said, find the length of DE. So now to calculate the length of DE, we can say DE is, the ratio of DE is 4P over the total of what? 9P multiplied by the total length of CE, which is 25. Then this will give us 4 over 9 multiplied by 25, which should be DE, is equal to 100 over 9, which can be written in decimal form as 11.11 units. And that's how you calculate that. So you're just making use of the information that you are already provided with. So you all base it on this ratio here, which is CD over BA. So yep. And that's it, guys, with the questions. So we'll just end our lesson here. Thank you for tuning in. Keep on watching the lessons and then practice with more questions. You know, that's always the antidote With more questions that you practice, the less anxiety that you'll have when it comes to writing your exams. With all that being said, danko. See you next time.